In Chapter 10, we're going to study a very brief introduction to statistics. And the first thing we're going to look at is some types of tables that display data, particularly a frequency table. If you look in the book on page 512, example problem 1, we're given some data of tuition costs. It reads, the following list contains the 2017-2018 annual tuition in thousands of dollars for a random sample of 30 community colleges. And it has 1.1, 1.4, 1.4, 3.7, and so on. And those are in thousands of dollars. So 1.1 would be 1.1 thousand, or 5.9 would be 5.9 thousand, and so on. And underneath that, they have what's called a frequency table, or some books will call it a frequency distribution, where the data are grouped together. If you look at that table that's at the bottom of page 512, you'll see that the group of 1.0 thousand to 1.4 thousand has a frequency of 5. That means 5 of those values are between 1.0 and 1.4. And the way we would draw that on what's called a histogram, oops, let me switch colors here. We would draw a bar from 1, starting at 1, that goes up to 5, because that category had a frequency of 5. The next category, starting at 1.5, has a frequency of 0. So we can kind of skip over the bar starting at 1.5. Then the category starting at 2.0, you'll notice if you look at that table in the book, 2.0 to 2.4 has a frequency of 1. So the bar starting at 2, what was that? It has a frequency that only goes up to 1. Next, the bar for 2.5 to 2.9, it has a frequency of 5. So our next bar, which is, you'll notice, touching the other one, has a frequency of 5. The bar starting at 3 should have a frequency of 1. Then we have our biggest category. The bar starting at 3.5 should have a frequency of 9. So that's going to go up to about right there. Then let's see, the bar starting at 4 has a frequency of 4. The bar starting at 4.5 has a frequency of 2. The bar starting at 5 has a frequency of 2. And the bar starting at 5.5 has a frequency of 1. This is an example of what we call a histogram. It's a type of bar graph that's used for displaying this type of data. And here we can see where the highest group is and how it kind of tapers off a little bit on both sides. Okay. Now, one thing we can't tell just by looking at this chart, we can't tell what the individual data values are. We could if we go back and look in the book, but just by looking at the chart, for example, I know there's 9 different data values here, somewhere between 3.5 and 4, but I don't know what those were. I don't know if it's 3.5, 3.5, 3.5, or maybe it's 3.5, 3.9, 3.7, 3.6. I don't know what the exact individual data values are. So if what you want is a quick visual picture, this type of histogram is great. Histograms are very good for giving you a quick visual idea of what we call the shape or picture of the data. But what you can't see in a histogram is the individual data values. So if you want to see the shape of the data, but still also be able to see the individual data values, you'll often make what's called a stem and leaf plot, where you take a number like 1.3, say, and 1.3, you would split it up into a stem of 1 and a leaf of 3. Here's an example of a stem and leaf chart that shows the same data as our histogram up above. So what you can see here, for example, when you have a stem of 1 and a leaf of 1, that tells me my data value is 1.1. The next one we would have 1.2. The next one, 1.4, 1.4, 1.4. Or down below, you would have things like 4.2, 4.2, 4.4, 4.4, 4.7, 4.9. In other words, here you can see all the individual data values. You can still see the picture of what's going on with the graph. If you notice, if you were to turn that stem and leaf chart sideways, it would have a very similar, or the exact same shape actually, as our histogram that we had up above. Now, the good thing about stem and leaf charts is you can see the shape and picture of the data while also being able to see the individual data values. A weakness is it can sometimes be a little confusing to read, and it takes a lot longer to make, because instead of just drawing a bar up to, say, 9 for a group, you have to list all the individual data values. It takes a lot longer, and it can sometimes be more confusing to read. Now, another thing that's very important with regards to these pictures or that show us shapes of data is to understand what we mean by the shape of a distribution. And we've got 4 shapes we're going to talk about. First is what we call a uniform distribution. And there's an example in the book at the bottom of page 515. They have 4 different graphs that just show you examples of some of these shapes. Shape A is a uniform distribution. In a uniform distribution, all of the groups are approximately equal. They don't need to be exactly equal. They're usually not exactly equal, but they should be pretty close to each other. So what we mean by that is all of the bars in a histogram would be at about the same height. This one's definitely not uniform. The bars have all completely different heights, so that would definitely not be uniform. But if you look at graph A at the bottom of page 515, that one, the groups are really approximately equal. Now, the next one, which is probably the most important one for what we're going to be studying later on in this chapter, is what we call a normal distribution. And there's an example of one of these shown in graph B at the bottom of page 515. A normal distribution graph, sometimes it's called bell-shaped. Its highest part is in the middle of the graph, and then it tapers off equally on the sides. So it's higher in the middle and lower on the sides. And it's not really longer on one side or the other. Then you have what we call a left skewed graph. There's an example of one of these in graph C in the book. And here you have a tail that is longer on the left side of the graph. And then you can kind of guess that right skewed, which is shown in part D, means that the tail of the graph is longer on the right side. So in a uniform graph, the categories are all pretty close to the same. A normal shape of a graph means it's higher in the middle and lower on the sides. So something sort of like this. A left skewed graph means that there's a longer tail on the left side. So something like that. And then a right skewed graph means that there's a longer tail on the right side, like that. Looking at these shapes of distributions is something that'll be very important for the type of things we study later on here in chapter 10.